to demonstrate on how to calculate simple linear regression manually. Okay, so basically I'm going to make use of an Excel spreadsheet to demonstrate how all these values are calculated. Okay, so let's look first. This is the data example. So for the data example, we have about 32 data set. These 32 data set are for the cholesterol level and its effect on the blood pressure for systole. So right now we have, allow me to demonstrate the data set. So we have these 32 data set. Okay, so we are going to calculate the simple linear regression. So to get the simple linear regression, we first have to get the regression coefficient. For the regression coefficient, this is the formula for the regression coefficient. So as you can see, for the regression coefficient, we need the sum of x, we need the sum of y, the sum of xy, the sum of x squared, and the sum of x. Okay, so for that, we have this spreadsheet. So we're going to take advantage of the spreadsheet to calculate all this. So here we have the cholesterol level. This is x. This is the blood pressure systole. This is y. Okay. So to get the x and to get all the values here, so allow me to demonstrate here. So first we're going to take this value, then we're going to square it. Okay. For this one, we're going to take this value, then we're going to square it. Then for this, we're going to multiply the cholesterol and the systolic blood pressure. Okay, this one we cannot do anything yet. First, for this cells we cannot calculate anything yet. This one we can calculate later. Okay, but we will do that together with the rest. Okay, so we are going to settle this one first. So we're going to pull down all the way down. Okay, so we got all the values already. Okay, so since we got all those values, so we can get the sum for it. So to get the sum for it, it is a simple matter of highlighting one column all the way till the end, to the bottom. Then click on auto sum. So to click on the auto sum, okay, so here we have the home button. We click on auto sum. So immediately the value is given at the bottom. Okay. Okay, this auto sum, we just select on the left side, pull it, so you got the value for the rest. Okay, for us to get the value of the regression coefficient, we need to get the sum of x, the sum of y. Okay, so I'm just going to put it down here, sum of x, the sum of y, the sum of x squared. Okay, we need to expand this space a bit. The sum of y squared, and then the sum of xy. Okay, so you can see here the values are already all there, so I'm just going to pull it out. Okay, so the sum of x, the sum of y, the sum of x squared, okay, not enough space, the sum of y squared, and then the sum of xy. Okay, let's do the first part of the formula. So the first part of formula is the sum of xy minus the sum of x times the sum of y divided by n. Okay, so n we know already is 32. Okay, n is 32. Okay, so let's do the first part. So for the first part, this top part, okay. So for the top part, okay, we're just going to put b equals to. So the top part is this sum of x times sum of y. So I'm going to take advantage of that. Okay, sum of x multiply with the sum of y. Okay, then divide by n. So divide by 32. Okay, so we got part of it. Okay, so now to complete the top part, we have the sum of xy minus that value. So the sum of xy minus that value. So for that, we just put in the formula. Okay, the sum of xy minus these values. So to ensure that everything is done correctly, we just put everything in the bracket. Okay, so that this thing goes first. Okay, so we got the values already there. So now let's see the bottom one. Okay, let's see the bottom one. Okay, for this one. Okay, so the bottom one is the sum of x squared divided by n. So we're going to do sum of x. So sum of x, you square it, then you divide by n. Okay, so first you get that value. Okay, sum of x. Okay, so now you put in the bracket. Okay, now we're going to put in the other half of the formula, which is the sum of x squared. So the sum of x squared minus that value. Okay, so you got the value of 47667 for that. Okay, so now we have these two values together. So let's get the final value of the regression coefficient. So the final value of the regression coefficient is b equals, okay, so you're going to have this value divided by E43. Alright, okay, and so that is our value of the regression coefficient. So for the formula, it is y equals a plus bx. So I just type down the formula. Y equals a plus bx. Okay. So if you just want to have the value of a, so you rearrange the formula. So become a equals to y minus bx. So we already have the value of b, the regression coefficient. So now we need the value. Okay, we need the value of the other members, the x and the y. So where do we get the x? We take advantage of these two values. Okay, so these two values, we need the value of the x and the y. Okay, this one, let's highlight this first. Put b. So that's important value. Okay, so for this x and y, so this is the mean of x and the mean of y. For the mean of x and the mean of y, it is very easy. Equals to the sum of x divided by the n. Okay, the same applies for the mean of y. It is the sum of y divided by n. Okay, so now we got the x and the y value already. So we got the x and the y value already. So let's get the answer for A. So for A, okay, so for A equals, okay, okay, as stated as now is y minus bx. So y minus b times x. So b, this is b, times x, this is x, bracket. So now we have the value of A. Okay, so now we have done simple linear regression. So we got the formula already. So this is the formula. Y equals A plus bx. So since A is 145.82 and B is minus 0.005, so this is the value that we got. So now, based on this value, we are going to calculate the value of the Y fit. So to get the value of the Y fit, we're going to copy this. Copy. Okay. So we're going to paste it up here. Okay. So we're going to calculate the value of the Y fit. Okay. So how to calculate? So we click on this one. Okay, escape. We click on this formula. We copy the last part. Control C. We go up to the top part. We put equals. Then we paste. Okay. And now we have this x. The x we have to change to become the value of x. So for x here is the cholesterol. So the chol. So we're going to put in B2. Okay. We press enter. We get the value of the Y fit. Okay. Why do we need to get the value of the Y fit? Because the formula, okay, the formula to calculate standardized deviation of the residual, okay, the standard error of regression coefficient requires us to have the difference of the Y and the Y fit. The Y is the observed data, the Y fit that is based on the formula. So that is why we need to calculate the Y fit first and then get the difference. So this is the formula. Okay. So now we are going to calculate the Y fit first. So how to calculate the Y fit? We highlight this thing, we pull it down all the way to the bottom. That way we get the Y fit. So now for the Y fit, so now we need to get the difference of the Y and the Y fit. So we know what is the Y? Y is the systolic blood pressure. So this is the systolic blood pressure. Then we minus the base on the fit. So the fit is 144. That one just the difference. Remember, we have to square it. So we have to square it. So we square it. Press enter. Then we pull it down all the way down. Okay, and that's how we got the value. For the last part, remember the formula also requires you to know the difference of the x with the mean of the x. So for that we need to do this one. So what is the x? This is the x. What is the mean? So the mean is already calculated down here at the bottom. Okay, B35. To ensure that the formula works, we just put in the $sign. Okay, so that the formula stays the same. Then you put in the square, enter. Okay, now we pull it all the way down. We're now okay. So now we put, all right, and So from there, you can calculate the rest. So you can see to get the standard deviation of the residuals, you need to get the value of y minus y fit. Okay. Okay. So divided by n minus 2. So here there's the value 80,643 divided by 30. You get the standard deviation of the residuals, which is 24.92. So the standard deviation of residuals, we divide by this value, the x minus mean of the x, then you square it. So that is the value here, 24.92858607 divided by the square root of 47,666.88. You get a standard error of the regression coefficient of 0.114179807. So here you can see to convert from the standard error here to become the t value. So then from the t value you can get the p value. So from the t value you divide with the b, the beta, the regression coefficient, divide by standard error. So you get minus 0.05 divided by 0.11. You get a value of minus 0.048. This one, if you refer to table A3 for degree of freedom of 30, you will see that the p-value is larger than 0.5. I'm going to show the formula. So you can see at my back is the formula. So we're going to scroll up until we get the for the degree of freedom of 30. So this is the degree of freedom of 30. As you can see here, for p equals 0.5, your value should be at least 0.68. Our value is only 0.048, which is smaller than this. So therefore, the p is already larger than 0.5. Okay, I'm sorry, I cannot zoom in for SPSS. So click Analyze, Regression, Linear. So I know you cannot see the screen. Very sorry. So cholesterol is the risk factor. BPS1 is the dependent. So I'm going to click OK. So now we got the output. Again, the output cannot be seen. Okay, so I'm going to change the window capture again to the output. So you can see there at the bottom there on the left side. Okay, so the value is similar. The value of the regression coefficient is 0.005. The value of the constant A is 145.821, which is the same. The t value is minus 0.048, same like what we got. And here the p value is 0.962, and we got the p value larger than 0.5, so it is the same. So in fact, what we did manually gave the same answer like if we are using SPSS.